So when we say rationalize the denominator, let's see if we can understand what we mean by this. Well, a rational number, 15 is a rational number. Root 5 is not a rational number because when you look at it on your calculator, it's a long decimal number which doesn't end and doesn't have a pattern. So, for example, 1/3 also never ends, but it does have a pattern. So we can rewrite that as 0.3 recurring, whereas the square root of 5 does not have a pattern. So it's just random numbers you can't really predict exactly. So, and the word denominator, that's the number along the bottom. So when we have a fraction, we have the denominator and the denominator, and the number on the top we call the numerator. So when we rationalize the denominator, we want to somehow turn this number at the bottom into a rational number. Well, how would you rationalize root 5? You would multiply it by root 5. That's one way you could do it anyway. That's the most obvious way, at least. And you'd get 5. But we can't just go ahead and just randomly do that. There's a little trick. What we do is we multiply it by root 5 over root 5. And, well, root 5 over root 5, whenever you divide one number by anything by itself, that's what 1 is. So all I've done to this is just multiplied it by 1. And there's nothing wrong with that. I'm allowed to multiply this by 1. So when I do that, I get at the bottom, well, root 5 times root 5, which we know is 5. So I now have a rational denominator, so I've rationalized the denominator. And at the top, I get 15 root 5. And that can be simplified because 15 divided by 5 is 3. So the answer is 3 root 5. Okay, so let's now have a go at 10a, which is a similar sort of thing. So basically we are going to multiply it by root 3 over root 3, which is just multiplying it by 1. The bottom ends up being 3. The top ends up being 12 root 3. So yeah, 12 divided by 3 is 4. So 4 root 3. Now, that's the first level of difficulty when it comes to rationalizing the denominator of a surd. I don't think this worksheet has the next level of difficulty in it. So I think I will have to come up with my own question on that. Let's imagine we had, maybe I'll use black here. Let's imagine I had 3 over 2 plus root 5. Now, this is more complicated because what do I need to multiply? I mean, I know that I can use probably a similar trick where I do something divided by itself, but what would that something be? How would I, what would I need to multiply by this that would produce a rational number? So what we're going to do, well, actually, let me just pause. Maybe you know this already. So we're going to use something called the difference of two squares. And we'll learn why it's called the difference of two squares in a moment. Difference of two squares. If I had a plus b multiplied by a minus b, and I factorise that, I would have a squared plus a times b, or b times a, then minus a times b, and then minus b squared. Now you can see the two terms in the middle, they cancel out. So I just end up with a squared minus b squared. in other words, the difference of two squares. So when we take away one thing from another, we get the difference. And these are square numbers, or squares for short. So this is why it's called the difference of two squares. So how is this going to help us? Well, if I've only got square numbers, then if I square, then that means I could end up with just somehow doing a little trick where I end up with 2 squared minus all of this squared, which will be a whole number. So I take this bit here, 2 plus root 5, and I do the opposite of that, or not the opposite exactly, but I take this thing here and I go to minus root 5. And at the top, I need to put the same number, the same value. Otherwise, I would be changing the expression. And now at the top, let's just do the top first. It's going to be 3 multiplied by 2 minus root 5, all divided by, and we're going to expand this out. So 2 times 2, which is 4, plus 2 root 5 minus 2 root 5, and then we've got root 5 times root 5, but the one's negative root 5, so it's going to be minus 5. And just like the bit below, these two cancel out. So I end up with just 4 minus 5. So, and that's 1. Oh no, it's not. It's minus 1. So where we got, and let's expand. So let's put the minus 1 at the bottom first. And at the top, 3 times 2, which is 6. And 3 times root 5, which is 3 times minus root 5, which is minus 3 root 5. And because we're dividing it by minus 1, which is just the same as timesing it by minus 1, I take each of these terms and I multiply it by minus 1, so that would end up being minus 6, and this would end up being plus 3 root 5. So I could switch them around. There's my plus 3 root 5, 3 root 5, and there's my minus 6, and that's the answer. And we can, whenever you're unsure of this, just like we can do this with all sorts of surds calculations, just tap all that into your scientific calculator, or just tap this one into my scientific calculator, and it should simplify it to this if we've done it right. So let's give that a go. So that's how we rationalize the denominator when it's a little bit more complicated, like this. Okay, and it does get even more complicated than that, but that's more taken by a case-by-case basis. In fact, I don't think you'll get more. I'm probably thinking of more complex algebra. I don't think you'll get any more complicated than that in surds. You might get like combinations of this and other things. But so I think we can do all these questions now on this worksheet, and we may want to get more tricky ones. Okay.